AI is accelerating software delivery, but it's also making production environments harder to observe. Applications now span Kubernetes, virtual machines, cloud services, and AI agents, while code changes constantly and the telemetry becomes fragmented. Odigos solves this by using eBPF-powered instrumentation without code changes, SDKs, or developer involvement, delivering consistent, production-ready observability across modern infrastructure and AI workloads. Instrumenting new services with Odigos only takes a few clicks. You can selectively instrument specific namespaces and deployments, and Odigos automatically detects newly deployed workloads. This allows teams to easily extend observability across their environment without restarting applications or relying on developers to add instrumentation. Configuring destinations with Odigos is just as simple. Teams can route telemetry to the observability platforms they already use. Because Odigos is built on OpenTelemetry standards, telemetry remains portable and vendor neutral, eliminating long migrations between APM vendors and avoiding vendor lock-in. For this demo, I'll add a Grafana LGTM stack as my destination. Odigos also gives teams fine-grained control over the telemetry they collect. Users can define instrumentation rules to capture HTTP requests and responses, database queries, and messaging payloads, while also enriching traces with code-level context like file paths, line numbers, and stack traces. Custom HTTP headers can be collected dynamically, making it easy to capture tenant IDs, session identifiers, AI correlation IDs, or other business-critical contexts directly within traces. When deeper visibility is needed, Odigos supports custom instrumentation without manual SDK work. Using continuous profiling and runtime visibility, teams can identify uninstrumented methods in real time and add custom code automatically. This is a major shift from traditional instrumentation models that require developers to predict observability needs ahead of time. Teams can visualize profiling data within the Odigos UI or export it to compatible profiling backends, making it easy to correlate performance bottlenecks with distributed traces and application behavior from a single telemetry pipeline. To see everything working together, we'll generate a real distributed trace using the ODMall application. We'll walk through a complete purchase flow, browsing the storefront, viewing a product, generating an AI product description, and completing a checkout. You'll notice that the AI response doesn't complete successfully. We'll come back to that shortly. With the transaction complete, let's move into Grafana and examine the traces generated by the request. In the checkout trace, we get deep visibility into the full request flow, including HTTP payloads, database queries, Kafka messages, correlation headers, code-level metadata, and internal database spans. We can also immediately identify issues, like a database locking wait timeout during inventory updates, without requiring developers to add custom instrumentation or debugging logic. Odigos even surfaces custom Java business logic, like this custom Java method we defined earlier, process request. From the trace, we can inspect the method arguments and return values in real time, giving teams application-level context that would traditionally require custom tracing code and redeployment. This is where runtime visibility becomes especially powerful. Instead of relying on developers to predict what should be instrumented, Odigos captures critical behavior as production systems evolve. We can also see Odigos capturing an AI request as part of the same distributed trace. The Gemini span shows the product service calling Gemini to generate an AI product blurb, including model metadata, token usage, latency, completion details, and the outbound request to the Gemini API. We can even see the reason why the response never completed in the storefront. We hit our max token limit. This makes AI interactions fully observable rather than a black box. Teams can understand which services invoke the model, how many tokens were consumed, how long the request took, and where failures occurred. all within the context of the user transaction that triggered them. Modern applications need observability that can keep pace with rapid change. With Odigos, teams can automatically instrument workloads, standardize telemetry with OpenTelemetry, and gain deep visibility into applications, infrastructure, and AI workloads, without developer effort or vendor lock-in. The result is observability that's simpler to deploy, easier to scale, and built for the next generation of AI-driven operations.